Right then, the equals symbol used in computing. Now, a little bit of history. So the beginning of the equals, it was created by a man called Robert Record from Wales. He was born in 1512 and sadly died in a debtor's prison in 1558. But during his life, he came up with this amazing thing. He was a bit of a mathematician, and in his own words, to avoid the tedious repetition of these words is equal to, I will set, as I do often in work use, a pair of parallels or Jumeau lines of one length, thus equals, because no two things can be more equal. Ironically, he also introduced the plus sign to the English-speaking world, although that was invented before him. Okay, now, the other thing I want you to think about is remember variables. Variables are very similar to algebra. It's like a box which can contain data. The thing is, we give it a name. So I'm going to call this one x. So here's my variable box, and it's called x. And I can store different bits of data in there. So in goes a 3, and now x is equal to 3. Or I can take that data out, and I can put, say, a 5 in, and we would write that x is equal to 5. So that is a variable. Okay, now let's look at some maths. X equals x plus 1. This is impossible, certainly in mathematics. For example, if I was to replace the x with a 2, and say 2 is equal to 2 plus 1, therefore that equals 3, so 2 equals 3. Well, that's stupid, 2 doesn't equal 3. But in computing, this kind of thing happens all the time. Let's look at the maths. If we take this equation again, but let's write it without the equals. Let's go pre-Robert and say x is equal to x plus 1. That's what we're saying in natural mathematics. And then if we replace the x with, say, 5, 5 is equal to 5 plus 1. Well, this is silly. However, computing doesn't work like that. In computing, on the left-hand side is the future value. What it will be equal to on the right-hand side is its current value. So if we were to take our equation and replace it now in terms of the future on the left and the present value on the right, we actually say that the is equal to changes to will become equal to. So we've redefined the definition of what the equal sign means for computing. Now it all makes sense. So we can say, in English terms, x will become equal to the present value of x plus 1. And that's what we mean in computing about the equals. Here's a worked example. X equals x minus 1. And if we start with x being equal to 6, if we look here, we can see now that x equals 6 minus 1, that's fine. So x equals 7, that's fine. So now we can go, we've worked all the right-hand side of the equals out. We can say 7 equals 7, x equals 7. It's that simple. Okay, so that's how we deal with equals in most cases, but you can confuse a computer. It's very easy to confuse a computer. Think about the sign. Let's start by thinking about z equals 5, or instead of saying z is going to be equal to 5, let's ask a question. And the question is, if z equals 5, then begin or do something. I don't really care what. Yep, it's a question. Now, the problem with asking this is in many computer languages, it gets confused because when it tries to understand what we've written, remember, it doesn't speak English, it's translating into machine code. So the first thing it will do is it might well translate the z equals 5 to mean 5 equals 5. So it then gets around to asking the question, only it's now saying if 5 equals 5, then begin. It goes, well, of course 5 equals 5. And it will always give a yes. It will always do it. So yes, I'll begin. Of course I will. So to avoid that happening, what we do is we replace the equals with a double equals. And in some programming languages now, if you see the double equals, basically that's to tell the computer, I'm not telling you that z is going to be equal to 5. I'm asking you, is it equal to 5? And now the computer doesn't get confused. Right, there's one last time when equals isn't always as it seems, and it's the plus equals. Here I've got a variable called myVariable, and I've said myVariable is going to equal myVariable's present value plus 1. Okay. Instead of doing that in the same way that Robert decided he didn't want to have to keep writing out the same thing time and time again, computer programmers decide they don't want to keep writing out the second myVariable time and time again. It's inefficient programming. Instead, they've come up with a brilliant way of doing it. Is myVariable plus equals 1. It does exactly the same job as above. You can do it with minus as well. So yeah, another variable is equal to another variable will be equal to the present value of another variable minus 1. And that gets rewritten like this: another variable minus equals 1. And it's that simple when you come across this. Okay, there you go.